In the last section, we talked about central angles, which were angles with their vertices on the center, so the vertex was on the center. And in this section, we're going to talk about inscribed angles, meaning that their vertex is on the circle. And we've talked about this before, or talked about the idea of inscribed and things being inscribed, but now we're going to actually work with their measurements. So we're going to find the measure of inscribed angles, we're going to talk about inscribed polygons, and then we're also going to do a little bit with some tangents. So let's start with an inscribed angle. Well, it's an angle whose vertex is on the circle, so for example right here, and the sides, meaning AB and BC, so AB and BC are the sides of the angle, sides of angle ABC. And so those sides are chords, so they have endpoints here and here as well. An intercepted arc would be the arc that is on the interior of that inscribed angle. So for this example right here, arc AC would be the intercepted arc. So intercepted arc for angle ABC. We have an inscribed angle theorem, and what that is any angle that's inscribed in a circle, so again, meaning the vertex is on the circle, the angle is half of the arc, or if you work it backwards, then you can double the angle to get the measure of the arc. So here's our very first example. We are looking for x in this case, and what we do is take our 3x and set it equal to half of our arc. Remember, your angle is half of the arc measurement. So we end up with 3x equals 69, I believe. We divide by 3 to get x is 23. There we go. Number 2, again, we have an inscribed angle, and this thing means 90 degrees. So if this is 90 here, then we say that the angle, which is 90, is half of its arc, so 4x plus 8. And so we get 90 equals, and distribute the 1/2. 1/2 of 4x is 2x, and 1/2 of 8 is 4. Subtract 4 from both sides of your equation to get 86 equals 2x, and divide by 2. X is 43. Now a second route, since you know that this is 90, that automatically makes this arc from here all the way around to here 180 degrees. So you could also do 4x plus 8 and set it equal to 180 and solve that way and still get the same answer. So, and that's since you know that that's 90. And our third example here, now remember in one of the sections we covered earlier, congruent chords form congruent arcs. So this arc would be congruent to this arc over here, 110, so this is 110. In order to get this one over here, we're going to take 360 and subtract our 110s from it to get a total of, what, 360 minus 220, so that is 140. So if this arc right here is 140 degrees, so that's from here all the way around to here, then x is half of that arc, and half of 140 is 70, so that angle right there is 70 degrees. Now we have two inscribed angles. And when you have two inscribed angles in a circle and they intercept the same arc, meaning they form the same arc, then those angles are going to be congruent. So since angle 1 and angle 2 both intercept arc BC, so BC with the arc on top, then angle 1 is going to be congruent to angle 2. So if you follow the sides of angle 1, here's the endpoint here, here's the vertex, and here's its other endpoint. And then when you follow angle 2, it has the same endpoints just with a different spot. So these are actually congruent to one another, which makes it kind of nice. Now in the same way, angle B right here forms this arc, and angle C has those same two endpoints, so that one, those two will be congruent to one another as well. So in this example, we don't necessarily have to find the measure of the arc to be able to get the measure of the angle, or vice versa. So if I'm looking to find x, w, z, and then wx, the arc, well, look at this right here. Angle x is 22 degrees. Well, angle x forms this arc right here, zy. Well, if you notice, angle W has exactly the same endpoints. It also forms zy. So angle W is congruent to angle X because they form the same arc. So angle W, the measure of angle W, is going to equal 22 degrees because the angle X is 22 degrees and they're the same. Now to get X, meaning this X, look at angle Z and angle Y. They both form this arc over here, and because of that, they are equal to one another. So we will take our 3x minus 23 and set it equal to 2x plus 2. Subtract 2x from both sides of your equation to get x minus 23 equals 2, and then add 23 to get x is 25. Okay, so x is 25. The measure of angle Z is a matter of just plugging x in. So we do 3 times 25 minus 23. So we get, what, 75 minus 23, which is 52. So the measure of angle Z, is 52 degrees. And then if we're looking for arc WX, well, that is taking the 52 here and doubling it because that is the measure of the arc. So 52 times 2, so to get your arc WX, is taking the angle, inscribed angle, and doubling it, giving us 104. And there's all your information. Now our next theorem that we have is if an inscribed angle intercepts a semicircle, then the angle is a right angle, which makes sense because we know that a semicircle means 180 degrees, and if this is half, when it's inscribed it's half, then half is 90, right? So this right here would be a 90-degree angle because BD is a diameter. Whoops, there we go. And then also angle A is as well because it has the same endpoints, BD, the diameter. So if we have an example like this, you'll notice that this right here is a diameter, which means from here all the way around to here is 180 degrees. And if this is 180 degrees, then this angle right here must be a 90-degree angle. So we take our 3x and set it equal to 90. Divided by 3 to get x equals 30. Our next example that we have is a quadrilateral inscribed in a circle, and what happens is your opposite angles are going to be supplementary. So angle E and G are opposite one another. They're going to be supplementary, so measure of angle E plus the measure of angle G is going to equal 180, and then the measure of angle H plus the measure of angle F is going to equal 180. So now looking at our next example, when you see that you have 1, 2, 3, 4 inscribed angles, we are going to work with opposites. So the Y and 87 add together to make 180, and then our 2x and 100 also add together to equal 180. They will be supplementary. So subtract 87 from both sides of your equation here to get y equals 93. There's your y value. And then subtract 100 here to get 2x equals 80. Divide by 2, and x equals 40. And there's your second answer. All right, almost done, just one more example, and this has to do with tangents. So if a line is tangent to a circle and you draw the radius to the point of tangency, so right there where it just kind of brushes up against the circle and keeps on going, this will be perpendicular every single time. And it doesn't matter where you put the tangent line, anytime that you draw that radius to that point of tangency, so the point of tangency is, oops, I didn't mean to draw that, there we go, is right there. So when we're looking at something like this, you'll see that this is a radius, so radius here. This WZ, that's a tangent. And what happens then is this is a right angle. And so what we have is a right triangle with 2 out of 3 sides. So with a right triangle and 2 out of 3 sides, we're going to do Pythagorean theorem. So a squared plus b squared equals c squared. Now your a, we're going to use 24. B, we'll use 10. And then this side right here is your c, so x squared. 24 squared is 576. 10 squared is 100. When you add those together, you get 676 is equal to your x squared. I'm going to bring this up here. I'm running out of room. We take the square root of both sides. The square and square root cancel on the right, leaving you with just x, and the square root of 676 is 26. Now, if we wanted to, we could go even further and say if this whole piece is 26, then this would be 10, and this would be 16, because this is just another radius from here to here. Just kind of an extra little side note. So make sure that you write all this down and come in with any questions.